Okay, so take out your packets for section 3.1, graphing relationships. We've already done the Stairmaster activity to understand about slope. So let's see. Go down. Oh, okay, thank you. Got this handout together. You've had some time to work on it on your own. So we're going to try to figure out how to represent situations as a graph. So segment 1 shows that the delivery van moved away from the warehouse. What does segment 2 show? So this is on the problem. The distance of a delivery van is from the warehouse varies throughout the day. The graph shows this distance from the warehouse for a day from 8 to 5. So when you're starting out on graphing, you always want to look at your x variable and your y variable and what those mean. Okay? So your x variable is what? Time. Makes your y variable distance. Always start there by looking at the labels. So this is the distance of the moving van over time. Now on the bottom, the x, that's your independent variable. So any guesses why your independent variable is time? What does it mean to be independent? Huh? Alone? Okay. So if you're independent, can I tell you what to do? No, Beyonce taught you that, right? So time, can you tell time to go backwards? No, so that's why we always put time on the bottom. So here's your independent variable, which is time. That is basically what it, I don't want to say always because there will be exceptions, but if you ever have two variables and you're talking about one of them as time, the time always goes on the bottom. Where does time go? The bottom. Good job. All right, and then you put your distance over here. So we have that segment 1 shows the delivery van moved away from the warehouse. What does segment 2 show then? Did it go back to the warehouse? If 0 represents the distance at the warehouse, did it go back? So what did it do? Kept going. Did it go faster though? Or slower? What do you think? Alright, so let's see. Let's compare. So to figure out if it went faster than number 1, I would drop the point at 1 and I would look at this amount. That's how much time it took to get to that point, right? Now if I look at the other, I drop this point here. That's how much time went by. So did I cover more height, more distance in this amount of time? Which one looks like it went faster? Here, let me do a more exaggerated example. So if I have this and I shoot up like that, and then I have this, which one looks like it would have been faster? The blue or the red? The blue. So the more distance I cover in a short amount of time, the faster the speed is. The more time that goes by, and if I don't cover that much distance, that means I went really slow. Because look how much distance I covered here. I only covered that much. Let's give an actual number. Let's pretend that's 5, and pretend that this is 20. So here, I covered 20 in whatever this time is, but on this one, I only covered 5 in whatever this time is. So I'm going to pretend this was 10 minutes and that was 2 minutes. So in 2 minutes, I went 20 feet. In 10 minutes, I went 5 feet. Long story short, if it shoots up quick, you went really fast. If it goes very slow, then you went very slow. Then shoot up real quick. Does that make sense? All right. So what do you think happens, though, when it's flat, like number 3? do you think happens if it's flat? Think of rise and run, right? Back to the staircase example. So here, I'm rising a big amount. So this rise represents your distance. And your run represents your time. I didn't want to write run again. I wanted to write time. All right, so write time. So here you have distance over time. What distance did you cover from this point to this point? How much of a rise did you have? None. How much time went by? Not much, just that little segment, right? Whatever this segment is. So 0 over any number, let's just say it was like 4 or something. What's 0 over 4? You have 0 slices of pizza out of 4 slices. What's 0 over 4? How much pizza do you have? None. 0. Okay. So if your slope is 0, what does that mean for this problem? How much did the van move? So how much did the van move from here to here? What do you think? Okay, let's put some actual numbers on this. I'm going to pretend like this was 10 and this is 14. Okay? So if this was 10, that's 14, and we'll say that this is 25 miles. So you have 10, 25 for the first coordinate. What would this coordinate be? What's the x? 14. What's your y? 25. Okay, did your y value change at all from this one to this one? What did the y value represent? Well, what does that 25 represent? What's the label? Distance. Okay. Did the distance change? No. So what happened to the van? What do you think could be happening to where he's just staying still? He didn't move. Could be that he parked somewhere. He was at a stop sign, right? Because we don't know how much. Remember, I made up these numbers 10 and 14. So we don't know if it was 4 minutes, 4 seconds. 4 seconds would be a stop sign. 4 minutes might be parking lot, right? Okay. What do you think this means? Okay, he's driving. Is it faster than 1? So remember, the quicker it shoots up, the straighter it is, that's the faster it goes. The flatter it is, that's the slower it goes, right? So is this one flatter than this one? It's kind of hard to tell. Look at your papers. See if you can tell, because on your papers it's right in front of you. What would you say, slower or faster? Faster? Yeah, it might be just a little bit faster. I think it might just go like 1 above it. Okay. What does 5 mean? If it's flat, what does it mean if it's flat, guys? Okay, he stopped. What does 6 mean? No? So this is where you got to look at the labels. Remember that my label is not about speed. So what do you think this means if I compare these two distances? What is it, the distance from? Okay, go back here, guys. Take a second. Read this part real quick. Everyone read that part. Okay. Now, what do you think that means when it goes back down? Okay, look. Let's say I was jumping, right? I jump like this. So this represents time like I said it usually would. Where's the highest point of my jump? In the middle. Okay, so this would be the highest point. What's the lowest point? When do I hit the ground? Is there only one time I hit the ground? Okay, when I start and finish. Now, what do you think the label is? Is it my speed? Height from what? Height from, what do you think? What did I hit? You told me I hit what? The floor, the ground, yeah. Alright, height from the ground, good. Okay, it's important that you know what you're graphing. So remember, we're graphing what? The distance of the van. Okay, so if we're graphing the distance of the van, what do you think it means when it goes back down? Is he now driving in reverse? You say, oh, I forgot something, and he puts it in reverse, and now he's going all the way back to the warehouse? Is he going negative speed? Okay, so what do you think it is? Okay, so, hold on. I'm realizing that I was making the same mistake you guys were. Remember I was saying these flat ones were stop signs? I was thinking this speed just like you guys are right now. What should the flat ones mean? Flat ones aren't stop signs. You could still be driving, but what are we representing if not speed? He could be still driving, or he could be at a stop sign. If you think about what you're graphing, what are you graphing? Distance. So think of on a map, here's the warehouse. So he drove away from the warehouse, right? And then he drove away, but it was at a slower pace. And now he's still at the same amount. So he could still be driving, but from the distance here, it could be the same amount, which is why it's flat. Or he could have just stopped driving like we said initially, and that's why it's the same distance. Okay, what about this one? Oh, sorry. So we're still on the negatives. What does that mean if it's going down for a negative slope? Okay, talk to people around you. Have a discussion about it. Let's figure this out. Doing this. All right, good job, guys. So it's going closer to the warehouse. So this isn't representing speed. So this isn't showing that he's going slower. This is showing that if you were on a map, he's just now making his way back to the warehouse. And you're graphing the distance to the warehouse. Okay. All right, so make sure you have these questions answered. And that is the only problem from this worksheet that we are going over. So we'll get back to those. I want to now move on to the videos. So these videos are going to help you with this idea. So instead of just pretending like there's a van there and you're graphing the van, these videos show you a situation and you're going to graph that situation the same way. So you have this worksheet. Make sure to pull this out. And let me explain what you're doing on this worksheet. So we're going to do 4 videos. Okay? You have a front side and a back side, 8 graphs altogether. Everyone have 8 graphs? Yep. All right. So on this side, right here, you're going to put your guess for your video 1. All right? And don't write video 1 So like the first one will be, what is the first one? The first one is that swinging. So they'll tell you a video title, put the title here, guess for, and then put your video title, okay? So it'll be something like swinging from a tree. So that'll be the first one we're watching. Swinging from tree. Now you're going to guess what your graph will look like. Ah! That's not the right answer if you didn't know. Then on here, answer for, and then swinging from a tree or whatever it is. Okay? And you're going to continue that, guess, answer. So make sure you have a guess, and then on this side, what is the actual answer? Don't erase it afterwards, so you can tell the difference between the two. That's how you're going to learn this credit, okay? Now, we're going to do this 4 times, which is why you have 8 graphs. Any questions before we play the video? Excited? Yeah? Oh, they're excited. They are. Oh, man. Okay. Here you go. Let's watch this video. Why isn't it letting me zoom? Let's try that again. I'm going to refresh the page. For some reason, it wouldn't let me go into full screen mode. Okay, hold on.